Hello ladies and gentlemen, this is All Outdoor One here. Welcome to another video. This one's going to be a bit different. Essentially, last year I started talking to this guy called Dave Budd. He's based down in Exeter. He's essentially a traditional methods blacksmith and toolmaker. He makes anything from Bronze Age jewellery to Iron Age axes to knives using more modern materials. And as a bushcrafter, for me, knives have always been of interest, and I've always, collected knives since I was relatively young, about 11, 12 years old, and the process of making them and shaping them has always been of interest to me. So I decided to book myself on a knife making course. This guy Dave Budd, he offers several different courses. For more information, please check out his website. I think it's davebudd.com. That's Dave, DAVEBUDD.com. As I said, he offers several courses varying in what you're making, from, as I said, jewellery to modern tools and equipment. So I went down there last week, and basically this was my creation. This is, when I went in there, I had a preconceived concept of what I wanted to make, essentially, and this is close to what I actually wanted to make. Obviously this is my first attempt ever at making a knife from scratch, and I'm pretty pleased with it, to be honest. It's shaving sharp, good thick piece of steel there, about 2 or 3 mils. Obviously all made by hand by myself, and it was a very interesting course. The location is, as I said, near Exeter. So it is quite far away from London, obviously, so I decided to make a couple of nights stay of it, and Dave was kind enough to let me camp on the land there, so did a bit of a couple of nights wild camping out there, and it's he's got a really nice setup there in the middle of his own private woodlands. There's a fire pit there, and he provides lots of wood. Had a nice trip, and he's an interesting guy. Now the way that I made this, obviously I had no previous experience, so I had to be taught everything from scratch. And so the way this was done was Dave would demonstrate one stage of the knife making process on a knife that he was working on separately, and then I would copy each step as we worked through it. I didn't bother to record myself that much working on this, because obviously you don't want to see my amateur fumblings. So obviously I just focused on Dave, and I think he explains everything pretty well. If anyone wants to know any more, then please get in touch with either myself or Dave. I just wanted to make a kind of survival stroke bushcraft knife. So I made a 7-inch beast, basically. I had wanted it actually to be a bit wider this way, but didn't quite get there. But I think this will still work really well. I mean, as far as paper tests are concerned, it is shaving razor sharp. I'll just give you a little close-up here. As you can see, I stamped my initials into here as well, which is a nice little touch. He has his own letter stamp set, and obviously drilled the holes to attach a handle, and another larger hole at the back for a lanyard wrist loop. I will be making a handle and sheath for this myself, independently of Dave, so it'll probably look really rubbish, but I'll give it a good try anyway. As you can see, I left the surface quite rough. This will not have any detrimental effect to performance or longevity, but I think it looks quite cool. And you know, I could have had a mirror polished surface, but decided not to. You know, I've got plenty of knives like that. I wanted to create something a little bit different. But yeah, that's the blade so far. Right, so that's what I'm making, and obviously Dave Budd is making a similar knife alongside. So I'll roll into the video now. It is quite long. Obviously the knife making process isn't a quick one, especially if you're doing everything by hand. So yeah, hope you guys enjoy. Yeah, be interested to hear any comments, questions. So this is Bushcraft Knife Making 101 from scratch, and hope you enjoy. Ready?
Stages in making a knife. First thing we're going to do is to take our parent bar of steel, in this case a piece of EN42J high carbon steel. First point is to make a point on the blade. The longer that point is, the more pointy and slender the blade is going to be. So if you want a very abrupt, short-nosed drop point, for example, you make a very short taper on the end of the bar. If you want a stiletto, something with very long, filleting knife type shape, longer point. Next step is to flatten it. We're going to flatten it to however thick we want the back of the blade to be. So in this case, about 4.5 millimeters. Once we've got it flattened for the length of the blade plus an inch or so into the tang, we'll redress the sides to bring it back into a uniform thickness and to make a more uniform width. So this is going to dictate how wide our blade is going to be. It also means that if our tip is swollen from the first process, or from the second process even, it will be tidied up, reset to one side. Once we've done that, we will make a mark, little mark where the cutting edge is going to extend to. The mark in the blade is very important, because when we come to forge the bevels in, if we don't respect that mark, we're going to grow and grow and grow, and you end up with a little short sword instead of a knife. Once we've done that, with the mark on the inside, we're going to curve it. So the cutting edge will be forged on the inside of that curve. The reason we do that is that when we come to forge the bevels in, so it tapers to an edge, so it's a full wedge-shaped cross-section, a proper knife, that is. Once we do that, the metal's going to spread, because we're moving the metal from the edge side, and it's got to go somewhere. If we don't do that bend, we get a banana. And it's an awful lot easier to stretch a blade that way, away from the cutting edge, than it is to try and bring one back down to the cutting edge. So the thin edge wants to crumple on itself. Once we've done the blade like that, we'll cut off from the bar using a hot cut and a chisel. And flatten out and draw out the tang to whatever shape and size we like. Mostly it's just reforging a flat bar to the same thickness as the back of the blade. When that comes back up to heat, it comes over to the anvil, edge up, with the end of the bar parallel to the edge of the anvil. So when we strike the corner to forge the tip, we're hitting air and hot metal, not anvil. If we've got it in the middle here, good accurate blows will place the hammer there. Brilliant. But if you don't strike it quite where you need to, you hit the anvil. Right. And that anvil's older than the pair of us put together.
Right, okay.
So I don't like to do that. The other anvil might be a little bit better for you because it's slightly higher.
Okay.
Again, try not to damage it. Because for some reason modern anvils are much softer than old anvils.
Right, okay.
Which means that they dent.
Right, okay.
That's too hot. That's what you don't want to do. That end where it's sparkles is now already cut off. Like,
okay.
So I'm just going to chop that off.
Right,
that's how we hot cut. The reason I cut it off is because when you overheat it like that, the crystalline structure of it grows hugely, which we can refine, that's not a problem. The main problem is the fact that the carbon burns out and there can be cracks set up in the metal that I don't want. So it's better to chop it off and waste that little piece.
sure.
Right. So I stood there talking instead of working.
Uh-huh.
notice what I'm doing is I'm holding it as firmly as I can so it doesn't keep shooting backwards, and I'm striking it so I'm pushing the metal into the corner. If you just come down like that, the metal's going to squeeze over the top and you get like a little mouth on the end, which is bad. That'll have to be cut off to redress it. But if you push the corner in, back into the bar, all's good. Every time it starts to spread out, turn it to the side and flatten it, just to redress it back to the original thickness. And keep working that until you get to the point. Like I said, the longer the taper you do on there, the longer the finer the point. So for the very deep belly drop point that you were after, we'll go a little bit more than that, but not a lot. Go.
But you will, obviously.
Not necessarily, it's quite a long blade. It might take Okay. Nice bright orange. Start at the tip, cutting edge down. Keep the blade parallel on the anvil so you've got somewhere to go to. Take it to about where your cutting edge starts. There we go. Okay, nice and hot. There's the cut. When you're cutting, make sure that after the first strike you put it back on the cutter because it will jump out. Cut most of the way through and then break it off. Normally I'd grab a pair of toms, but they're stood behind you. Okay, that's that. The blade is mostly forged to shape and cross-section. The tang is forged out to the right cross-section, right length. That end's done. So now we can go back to this end and finish forging the blade so we get it as thin as we want at the cutting edge, which is going to take it down to about 1 millimetre at the edge. And it will be one uniform cross-section, one wedge shape. At that point it should straighten up almost completely, and we can bend the tip up to where we want it. Finish that sentence for a minute. I'll go across the next one up. Most patination processes, such as rust for example, they convert the outside layer to a different oxide of iron, which is often more durable and less prone to fast rusting than bare metal finish. So to an extent it's rust proofing, but not particularly.
Right.
It's more really for stopping it from staining.
Oh, right.
Put an artificial patina on there.
Yep.
The patina that would develop normally through use, but would be uneven. You can make more uniform.
Right. Is that the correct pronunciation then?
What's that?
Patina.
That's how I pronounce it. Whether it's the correct one or not is a matter of the Oxford English Dictionary.
Okay.
Tomato, tomato. Okay, and I'll do the next one up on the next teeth.
Right.
Make sure your angle is clear. Yeah, so you don't inflect the scale into the surface. That's better. So, next thing to do is to straighten that up to whatever shape we want the blade to be. orientate the tang to the right angle. And that's quite a nice shape, is it?
It is actually,
Cab knife as it is.
Yeah.
It's a very aggressive chopping knife.
Right.
Just leave it like that.
Okay.
Or I can straighten things up. Quite a nice shape. Might just lift that tip up a little bit.
Right.
I think. Yeah, I'll
As in make it sharper?
Yeah, no, make it lift the tip up so that the tip comes up
right,
here somewhere,
okay,
so it's more
okay.
drop point than steer point.
Right, okay.
If it starts to try and turn on the edge, roll over, make sure you correct it before it curls over too far. Otherwise you'll end up hammering it in on itself and that'll be a great lump at your cutting edge. Okay. Tip's ever so slightly twisted. Okay, double check. Make sure it's still in line with the tang. It'll make grinding much simpler.
Sure.
So the blade's going into the furnace. I'm going to put it on one side of the thermocouple probe. Leave it in there. We'll put the other blade in there next to it in a moment. When the blades come up to the same temperature as the background, they'll disappear into the background. At that point, we'll take them out, leave them to the side to cool down. I'll retune the furnace to a lower temperature, and we'll do a series of subsequent normalising cycles before the hardening cycle. So. Make sure you put the angle guide down on its back. We've got really crap tracking on this, so I'm going to build a new one at some stage. Got to keep wandering side to side. Right, so you can see instantly where the high spots are, so if you wanted to take them off with an angle grinder.
So the edge.
I'll put the back done.
Flushing it out.
Basically what I'm looking for is one continuous silver line.
Yeah.
Just so I've got one long knuckle, lump. I don't want to take too much knuckle off because I don't want to thicken it up. The further you go into the blade, the thicker it gets. Now I'm just going to cut the burrs off. do a bit of cut that end off and draw some holes. Before I do that, I'm going to go get my knife out of the oven.
Okay.
Then I'll change the bit over and do the thumb hole. That go nice. The drill bit jammed a little bit because I, rather than buying a new drill every single time they get blunt, I regrind them. When I regrind them to be a bit more aggressive so they cut faster. The trouble is on the breakthrough, they grab.
I see. Okay.
So you have to be aware of it.
Okay,
Luckily, combining it with an underpowered piece of crap drill means that it stalls rather than ripping it out of my hand. Yeah. Handle. So, we have our blade with the holes marked out for our pins. These are cut for a 1/4 inch pin. They could be whatever size it needs to be. Handle material could be something that starts off nice and flat and uniform, such as this piece of micarta, which is a resin fabric laminate, which is impervious to moisture. It's very stable, doesn't shrink, doesn't swell. It's stiff, and the advantage is that, especially if you buy a commercially available one, it's flat to start with, which means you don't have to do any sanding to make it flat, or minimal sanding to make it flat. This is a bit of beech that I've milled up. So if I wanted to use wood as a handle, obviously start off with the sawn piece. If you buy commercially available scales from a knife handle supplier, for example, they usually come flat and sanded smooth as well. So most of the time you're going to get something that's flat like your micarta.
Right.
Either way, go through the same processes. The way I usually start is I start off by flattening at least the mating surfaces, so that the portion that's going to mate against the tang is flat.
Right.
You can use a belt sander if you have one, or a disc sander if you have one. If you don't have those, find yourself a piece of coarse paper, stick it onto a firm board like a sheet of plywood or a kitchen top.
Flat surface.
Sand it flat.
Sure.
Once you've got a flat surface, you'll need a drill press or the ability to drill a hole straight by hand. Drill one hole with it, so it's, if this is my flat surface that goes down, coming from the top, drill one hole, put a pin of the correct size in that hole to stop it from moving, drill the next hole, put a pin to stop that moving, drill the third hole, then take that away. If that's my new flat surface as well, put two flat surfaces together, put them down to the holes that are on the bottom side, switch them, so you've now got flat surface on the bottom, flat surface on the top, and the holes are on the top to use as a guide, so you can match up the grain in the wood. Drill the first one, pin, drill the second one, pin, third one, pin.
Sure.
Then all three pieces should fit together in the right place. Once you've done that, temporarily pin it in place onto one of your pieces, draw around the tang, draw the front of your handle whatever shape you want that, cut that front surface. If you want to cut some of that out, do so, but I wouldn't touch most of that shaping, because if it goes on slightly wonky, then you made a mess of it. But the front, where it's against your blade, shape that end in one, pin the two bits together as they're going to mate, shape the other one to match. So you can keep those two pinned together, actually pinned together like that, and with a grain. Keep them pinned together, shape and polish the front of the handle, because once that's on the blade, you can't get to it.
Right, okay, of course.
Shape them, Clean this up with a bit of sandpaper just to get rid of any crap.
Okay.
Degrease it with some nail varnish remover, acetone, alcohol, and then don't touch it. Any grease on your fingers will stop the glue from sticking.
Right, okay.
Give them a quick sanding on a 200 grit paper or something just to take any crap off there. Degrease, don't touch it. Your pins, these are loveless bolts, so these are threaded rod with a screw through them.
Okay.
These are available from places like Brissa and other knife making suppliers.
Alright, okay. These are specific for knives?
Yeah.
Right.
Yeah. And you get something called a Corby bolt, which is, instead of being brass and steel, you've got a brass lump with a screw thread on the end and a brass lump with a hollow on the end of a rod. But I don't use bolts very much. I tend to use pins.
Alright, okay.
So this
the
is a pin.
advantage being, or the difference being?
Bolts are expensive to buy. You also have to have a stepped drill bit, so you've got to drill, say, a 5mm hole for the shaft and a 8mm hole for the outside. You can get special drill bits that are tapered and stepped to do that, but I haven't got one. A pin, you can just buy a rod or a nail or whatever, the right size. Cut off the length that you need, sand that up a little bit to get rid of the oxides and the stuff that'll stop the glue from sticking. File a chamfer on the end, so when it goes through it leaves itself in. So all the bits will fit together, dry fit them all together, make sure it all works. Fine. Mix up your epoxy. Slow setting araldite, for example. Don't use the quick setting stuff, it's shit. It's brittle, doesn't work. Put your pins, dip the pin into a bit of glue, stick them through. Lather that with epoxy. Put your blade on. Lather that with epoxy. Put the next piece on. And then use a G-clamp, clamp front and back either side of the pin. Just hand tight pressure, don't over tighten it. And then leave it to set. Once it's set, take the clamps off, cut the pins down with a hacksaw. And as they block, shape the outside either with a sander or a rasp. Shape the outside with the handle to whatever shape you want, and then shape that plane.
How about if you're using the loveless bolts?
Loveless bolts, same. Basically, you put them through, tighten it up. You don't need clamps; they'll hold themselves. So just tighten those up. Leave it to set, and then shape it all. Wait till things come out. When you're doing it, make sure you're scaling from below the halfway mark. Don't come in that angle; it'll rip it out of your hand and take your fingers with it. Okay?
Slower than the sand themselves.
How do you mean?
It takes off less material at the time.
It's just taking off the loose bits on the surface.
Oh, so this isn't going to be used to make the edge, the blade?
No.
Okay.
Just cleaning it up to get the loose scale off the surface from the heat treating. Yeah. When you're going to tip, do it from the end rather than from the side.
When I'm doing the tip?
When you're doing a tip from the end, come down a bit like that rather than there, because your chances of hitting the tip there and ripping out your hand are quite high. one sharpened blade. Well, I say sharpened, ground to an edge. Almost there. Right, okay. Sharpening with a water stone. Try and hold the blade at the same angle that it was ground at. Do a full sweep with the blade so you can get the whole blade on that stone, maintaining the same angle. The key to sharpening is maintaining a consistent angle. You see some people going back and forth, or side to side, round and round, figure of eights and all that. I like to go in one direction at a time, because the more times you change direction, the more chance there is of you changing your angle. And it's 2 steps forward, 1 step back if you keep changing angle. So I work on one side only until I get a burr forming on the top surface, and I've got a consistent scratch pattern on the side that's on the stone. The consistent scratch pattern I'm looking for is a change from the 90° to the edge grit scratches from the belt grinder to slight angles, sort of 45 degrees to the blade, which is the direction I'm working on the stone. With practice, it's totally possible to get an almost perfect flat bevel. Now, it does take practice, mind. You also need a flat stone. If your stone's starting to hollow out through wear, you need to true it up by rubbing it onto a coarse, abrasive surface like a sheet of wet and dry paper, or better still, I use a paving slab with sandblasting grit or sand on it. That works nicely. If your stone's hollowed, don't press so hard. If the stone's hollowed, you're basically running your blade into a brick wall at the end of each stroke and blunting it.
That's okay, yeah. I can always do that at home, really, can't I?
Yeah, like I say, if you drop it in a bucket of vinegar overnight, it'll eat any scale off there, and then just use a Scotch-Brite pad like...
Yep. Yeah, so that was the process there. Quite a lengthy process, obviously. I mean, Dave Budd can do it a lot faster than I did, obviously, because, you know, he's an expert, he's been doing it for years. But yeah, it's well worthwhile taking a look at his courses and his products. Yeah, as I said, he knows a lot and he knows his stuff really well. So yeah, I hope you guys find that video enjoyable, and hope I was able, or Dave was able, to teach you something. I learnt a lot personally, and I'm sure you've learnt a few things too. So this is All Outdoor One, signing out for now. You guys take care. Bye bye.